Hello friends, let us study interpolation. In this we'll study Lagrange's interpolation formula in particular, wherein we'll go through two examples. One example we'll study the uh, application of Lagrange's interpolation formula to find the interpolating polynomial, and in another example let us study to find the value of y for a given value of x. So the example here is values are given. Y of 1 is -3, y of 3 is 9, y of 4 is 30, y of 6 is 132. Now we need to apply the Lagrange's interpolation formula and find the polynomial which will satisfy these sets of values. So let us write down the values once again by giving the values to these x, that is x naught is 1, x1 is 3, x2 is 4, and x3 is 6. Similarly, y naught is -3, y1 is 9, y2 is 30, and y3 is 132. Now we'll go for the Lagrange's interpolation formula. You know it, y is equal to, uh, we'll skip x naught here, x minus x1 into x minus x2 into x minus x3 divided by x naught minus x1, x naught minus x2, so on up till x naught minus x3 multiplied by y naught. Similarly, here in the numerator, x minus x1 is skipped. In the denominator, we'll take x1 minus each of the terms of x multiplied by y1. Similarly, in the third term, x minus x2 is missing in the numerator and denominator, x2 minus each of the values of x multiplied by y2, and in the last term, x minus x naught, x minus x1, x minus x2, we have skipped x minus x3 here, and denominator is x3 minus of each of the values, that is x3 minus x naught, x3 minus x1, x3 minus x2 multiplied by y3. Now just substitute the values of x1 3, x2 it is 4, x3 it is 6 here, then x2 minus x naught, x2, sorry, this term we are considering x naught minus x1, it is 1 minus 3, you have minus 2, then x naught minus 4, it is minus 3, x naught minus x3, that is 1 minus 6, you have minus 5, multiplied by y naught, it is minus 3. Now x minus x naught, that is x minus 1, x minus 4, x minus 6 will have, and denominator x1 minus each of the values, 3 minus 1 is 2, 3 minus 4 is minus 1, 3 minus 6 is minus 3, multiplied by y1, it is 9. Next term here, third term, x minus 1, x minus 3, then x minus 6. Denominator 4 minus 1, it is 3, 4 minus 3 is 1, and 4 minus 6, it is minus 2, multiplied by y2, it is 30. Last term, x minus x naught, that is x minus 1, x minus 3, x minus 4. X minus x3 is skipped here. Denominator term, x3 minus of each of the values of x. 6 minus 1, it is 5. 6 minus 3 is 3, and 6 minus 4 is 2. Multiplied by y3, that is 132. Now we will simplify this and we need to find a polynomial. So that is why we have kept x as x itself here. Now from these two terms we can see that x minus 4 into x minus 6, it is common. We'll take it outside. Then write down the remaining terms. It is x minus 3 divided by 3 has cancelled here. You will get 10. Now minus also cancels. You will get plus sign. Now here from this term already we have kept x minus 4 into x minus 6 outside. So what remains is x minus 1 divided by, we have 3 and 3 cancels here. We have 3 by 2 here multiplied by 3 by 2 with plus sign. Now you can see in these two terms, you can see x minus 1 into x minus 3 is common. Let us keep it outside. From the first term, cancelling 3 2s are 6 here. 6 with this 30, we have 5 into x minus 5 with the minus sign. Now here we have x minus 1, x minus 3 outside already. Cancel this 132 with the 6. Then we have 22 divided by 5 and the term x minus 4. Now we need to simplify this. Let us take LCM here and simplify. We'll get x square minus 10x plus 24. This simplification, x square minus 10x plus 24 divided by 10, LCM is taken. So taking LCM, we get x minus 3 plus 15x minus 15. Now in the second term here, x minus 1 into x minus 3 will give x square minus 4x plus 3. So that is written x square minus 4x plus 3 here, divided by 5 is taken LCM. Then taking 5 as LCM, simplify these terms, we'll get minus 25x plus 150 plus 22x minus 88. Simplify the terms, it is x square minus 10x plus 24. Then here if you simplify this, it is 16x minus 18. You can see that 2 is common, it cancels with this 10. We get 1 by 5. And what remains here is 8x minus 9. Now here also 1 by 5 is there, we'll keep it outside. Then x square minus 4x plus 3. Simplify these terms, we get minus 3x and plus 62. Multiply these terms, open the bracket, simplify, then we'll get this equation 5x cube minus 15x square plus 25x minus 30 divided by 5 is that. If you divide the whole equation by 5, we get the polynomial x cube minus 3x square plus 5x minus 6. That is the required Lagrange's interpolating polynomial. We can verify this answer by substituting the points in this. Take this equation in your calculator, write it in the calculator, then substitute x equal to 1. You need to get y equal to minus 3. You can check it for all the values. For x equal to 3, y should be 9, and for x equal to 2, y should be 30, and for x equal to 6, you have to get y as 132 here. Then we can say that the given whatever we have obtained, the formula or the polynomial, it is correct. Let us go to the next example. The following are the measurements T made on a curve recorded by oscillograph representing a change of current I due to a change in the conditions of an electric current. So T values and I values are given. Now they asked you to find the Lagrange's formula to find I at t equal to 1.6. Use the Lagrange's formula to find I at t equal to 1.6 is asked. Now here let us consider x instead of t and y instead of I for our convenience. Now at x equal to 1.6 we want the value of y. Now take the values here, given data as x0 x1, x0 is 1.2, x1 is 2, x2 is 2.5, x3 is 3. Similarly y0, y1, y2 and y3. Note them down. Then we will calculate x minus x0. X is 1.6 minus x0, that is 1.2. We'll get 0.4. Again x minus x1, 1.6 minus 2, that is minus 0.4. Then x minus x2 is minus 0.9, and x minus x3, it is minus 1.4. Now we go for the Lagrange's formula, interpolation formula. It is given by this one here. It is written y equal to, again x naught is skipped in the numerator, denominator terms, x naught minus each of the values of x multiplied by y naught, plus second term x1 will be missing in the numerator, that is x minus x1, denominator x1 minus each of the values of x multiplied by yn, y1, so on it is continued. Now let us substitute the values here. Y of 1.6 we want, so x is substituted as 1.6 here. Then we have already found the values, x minus x1 minus 0.4, here it is x minus x2 is minus 0.9, x minus x3 is minus 1.4. Now we need to know these denominator values. X0 minus x1, 1.2 minus 2, minus 0.8. Then x0 minus x2, it is minus 1.3, x0 minus x3, it is equal to minus 1.8. Then multiplied by y0, y0 is 1.36. Now go for these values, again Substitute all the values here. 0.4 into minus 0.9 into minus 1.4. Denominator, calculate them. 2 minus 1.2, 2 minus 2.5, 2 minus 3. Substitute them here, multiplied by y1, that is 0.58. Then again we'll go for x minus x0, x minus x1, x minus x3. So it is 1.2 into 2 into 3. Sorry, 0.4 into minus 0.4 into minus 1.4 divided by, we have the values x2 minus x0, that is this value, 2.5 minus 1.2, then 2.5 minus 2 and 2.5 minus 3. These values multiplied by y2. So y2 is 0.34. Now the last set, numerator will be 1.2 into 2 into 2.5, skipping the last value here. Now in the denominator, 3 minus 1.2, that is 1.8, 3 minus 2, that is 1, 3 minus 2.5, that is 0.5, multiplied by y3, that is 0.2. Just simplify each of the values here. We'll get the corresponding values of all the four terms, then add them. We'll get y of 1.6 is 0.8947. So you can check this value. You can see that 1.6 is between your 1.2 and 2. It comes here in this range, 1.2 and 2. Now the value of y should be between 1.36 and 0.58. You can see it is 0.8947. So that is actually the value of I for the given value of t, but we have written it in terms of x and y. Thank you.